Welcome. Today we'll talk about the maximum bending moment at a section in a beam or girder when a longer UDL, which means longer than the span, this AB span is 30 meters, which is considered. So the load being longer than 30 meters. So the span of the load is more than 30 meters. So using ILD concept, how we will find maximum bending moment at a section. Okay, so let me consider a load which is longer than the span. Let it be 10 kilonewton per meter UDL. Okay, right, so it is moving maybe from left to right or from right to left. Right, so you want bending moment. So draw ILD for bending moment at a section. So here, as you see, I have considered a beam of 30 meters and I have taken section at 10 meters from left. So C is located at 10 meters from left. Now plot ILD for bending moment at C. So this you have learned from the previous lectures that we have already discussed. Okay, let me go with a bit more ordinate. Okay, so that we will appreciate the value. Right, so herein it will reach 0 at the other end. This height at C, what we call YC value, the maximum ordinate of this ILD for bending moment is equal to X, that is 10 meters, okay, span AC multiplied by span BC divided by total span 30. Okay, so 0 goes here, so it will be 20 by 3 is the height of this ordinate. Okay, so this, how to find YC and what formula you shall be using, all this we have discussed in our previous lectures. Okay, right, now how to position this UDL to have maximum bending moment at C, because this UDL is moving from left to right like this, so it can have any position along this AB. The load may occupy only this much or maybe this much or maybe this much. Likewise, it can occupy any amount of span. So we know that as this UDL is longer than the span, it can occupy the total span of the beam, right? So I'll draw that. So now UDL is occupying the total span of the beam. So it is 10 kilonewton per meter. So now the function what we want here is bending moment at C. Okay, so the value of function is nothing but the UDL value multiplied by the area occupied by the UDL, area of ILD. Okay, so the area of ILD occupied by UDL is total area. Writing that total area, half base is the span itself, 30 meters is the base of the triangle. Height of the triangle is just found 20 by 3. Okay, Right. Now simplifying this, we'll have, right? So it is 1000 kilonewton meter is the bending moment value at C. This is the maximum possible bending moment in this girder because of this 10 kilonewton per meter load. Okay, at section C only, right? If you change the section to some other location, the maximum bending moment value will change, right? Right. So let us find the maximum possible bending moment in the whole beam. Okay. Now we have looked at section C only. So this is where I have found the maximum possible bending moment is 1000. So likewise, for any location, there will be a maximum value, right? So for all these locations, what will be the bending moment value, maximum value, right? So that we have discussed earlier, that the center of the beam is going to have the maximum bending moment. So let me draw the ILD for bending moment at center. D is the center. Okay, right. So it's just a triangle. 0 here, 0 here. I say YD, the ordinate at center. YD is equal to, the left span is 15 meters, right span 15 meters by total 30. Okay, so the value of ordinate is equal to 15 by 2. Okay, now the maximum bending moment at D, that means at the center, okay, will be, again, the load position is same as the earlier. The load has to occupy the total UDL, okay, total ILD shall be occupied, right? Then we will have maximum bending moment at D. So the function value, again, function here is bending moment, is equal to 10 into area of this triangle. Okay, this is ILD for bending moment at center. Okay, so half base height just found, it is 15 by 2. Okay, so working out for this, simplifying this is 5 goes here, 15. So this is 1125 kilonewton meter. Okay, now you can see bending moment at C, maximum possible value is 1000, and the bending moment at D, maximum possible is 1125 kilonewton meter, and this is the maximum value that is possible in the whole beam or girder AB. Okay, so this is what we call absolute maximum bending moment. Okay, so this is how we find bending moment at a section or the absolute maximum bending moment in the beam. Okay, so as you see, the ILDs have to be drawn for that particular position, maybe at a given section, and if it is UDL, use the function value as load multiplied by the area occupied by UDL. Okay, thank you.